I've been filming the Maths Countdown series for 100 days in a row now, and tomorrow is the final day of the series. So I've been leading up to this video for the past 100 videos, so make sure out of all the videos that tomorrow is the day that you don't miss. Okay, so for today's video, we're going to be deriving the formula for the volume of a sphere using integration. Okay, so over here, I have our sphere in 3D space on the XYZ plane. Now, in order to use integration to find the general volume of a sphere, what we need to do is we need to slice up our sphere, much like you'd do an onion, into an infinite number of slices. And those cross sections of the slices that we would have made will look something like this diagram on the right here, with smaller circles leading to larger circles in the middle, and then once again leading to smaller circles as we go to the outsides of the sphere. Okay, so each of these areas is going to be modeled by pi r squared. We know that. That's the formula for the area of a circle. Now, for this sphere, we're going to call the radius, which is going to be the same, obviously, for all points on the sphere. Our radius will be capital R. Okay, so if we were to look at the sphere from the z-axis, so if we were to stand over here, here's some eyes, and look along the z-axis, we'd be looking at this circle. Okay, and obviously this point over here then will be R, and this point over here will be negative R. And we need to find the area of all these circles that are sitting between negative R and R. So in order to do that, we need to calculate the volume using the integral from negative R to R, and we're summing up these areas. And the general formula for that area is pi r squared, so it's pi r squared dx. But now, the thing that you'll notice is that our radius varies as we move across the x-axis for the sphere. So the radius of all of these circles that form cross sections is going to be varying, and that's obvious because this circle, for example, is bigger than that circle. So we need to find a formula for the radius. Well, let's look at the general formula for this circle over here, which is the outside of the sphere. So we know then that x squared plus y squared is equal to r squared. Okay, well, let's write it in terms of x. So we'll isolate y. So then we have y is equal to r squared minus x squared plus minus the square root of that. So we know that r over here should be the same as this y, because this y is going to be the distance from a point in the circumference to the x-axis. And that'll be much the same, if we look over here, as this distance from the center of each of these circles to the top of their circumference. Okay, so we then know that this little r is equal to this y. So we can replace it with the square root of r squared minus x squared. And the square root of r squared minus x squared squared is just r squared minus x squared. So we can erase that, move this pi up, and we can have r squared minus x squared. Okay, so now all we have to do is solve this integral. So then we have the volume is equal to, we can take this pi out as a constant, and then we are evaluating the integral from negative r to r of r squared minus x squared. And then for this r squared, it's going to become r squared x, because it's a constant with respect to x, because we are integrating in terms of x. So now we do the integral of negative x squared, which will be minus x cubed over 3. And all of that, the bounds are from negative r to r. Okay, so now if we substitute in these bounds, what we get is pi into, substituting in r over here, we get r cubed. Substituting r over here, we get minus r cubed over 3. Then we're going to subtract this, evaluate it at negative r. So if we substitute negative r over there, we get minus r cubed. Substitute negative r over there, we get minus r cubed, but then it'll be multiplied by that negative, so it'll be plus r cubed over 3. And now, simplifying, we get the volume is equal to pi into, now this simplifies to 2 pi r cubed over 3, and what's inside this bracket simplifies to negative 2r cubed over 3. Now, this negative can distribute in, and then we'll be adding 2 pi r, or 2r cubed over 3 to 2r cubed over 3, and then we'll get the volume is equal to 4 pi r cubed over 3. And that is the general formula for the volume of a sphere. So I hope you found this video useful and interesting, and if you did, please don't forget to leave it a like and subscribe to my channel. And don't forget, tomorrow is the final day of this maths countdown. It's what I've been counting down until, and you're not going to want to miss it. Thank you for watching.